Good afternoon to all. I welcome distinguished guests, faculty members, staff, and dear students for the celebration of National Remote Sensing Day. This day marks the birth anniversary of the father of Indian space program, Dr. Vikram Sarabhai, whose visionary work laid the foundation for the remarkable advancement in remote sensing that we see today. It is a day of acknowledge the appreciate and the incredible contributions of remote sensing technology in various fields, from environmental monitoring to disaster management, urban planning, and many more. To commemorate this special occasion, we have organized a guest lecture on topic Trends in Remote Sensing by a distinguished expert in the field of remote sensing, Professor P.K. Joshi sir from JNU, New Delhi. But before we proceed, I request Professor Dr. T.P. Singh, Chairman, Indian Society of Geomatics and Secretary, ISRS Pune chapter, and Director, SIG, for welcome address. Over to you, sir.
Thank you, Dr. Rajesh. First, thank you to Professor Joshi. He kindly accepted invitation on this day as a speaker, and it was in very short notice. In fact, I spoke Dr. Joshi said a couple of days before about the how to celebrate such event, and I thought how the remote sensing has grown in that last 20 years and 25 years. Dr. Joshi has seen very minutely, in fact, the development of a remote sensing program, especially in India. Dear friends, that you all knows this day we are celebrating as a birth anniversary of Vikram Sarabhai, who is considered as a father of Indian space program. Vikram Sarabhai, who has started even that also that remote sensing program, and the first remote sensing satellite was launched in 1988 as a IRS 1A, and it was the very coarse resolution satellite, and then that it has become to the now we can see sub-meter resolution of or spatial resolution of Indian remote sensing satellite. Uh, I know that and I know this Dr. Joshi have a lot of experience the how to deal with the remote sensing data sets. What is the journey of the remote sensing program in the India in the last 25 years, especially in in application area in natural resource management, disaster management, because he has worked a lot in disaster management using remote sensing data sets, also the natural resource management. So I welcome Professor Joshi to address or to speak on this on occasion of Remote Sensing Day. So welcome, Dr. Joshi, and over to you.
Thank you, sir. Now, let me take this opportunity to introduce today's esteemed guest and speaker, Dr. Pawan K. Joshi, sir. Sir is currently working as professor at the School of Environmental Science, SES, as well as the concurrent faculty, Special Center for Disaster Research, SCDR, at Jawaharlal Nehru University, New Delhi. Prior to joining to the Jawaharlal Nehru University, he has the experience with Terry University for 8 years, and before that with Indian Institute of Remote Sensing, IRS ISRO, for around a decade. During serving at IRS, he was also adjunct faculty to the Center for Space Science and Technology, Education in Asia and the Pacific, and UN affiliated institution. He was visiting teaching faculty to University of Helsinki, Finland, then Yale School of Forestry Environmental Studies, USA, and University of Freiburg, Germany. He is trained as an environmentalist with specialization in satellite remote sensing and GIS. His research focuses on environmental studies, including landscape characterization and climate change. He has immensely contributed in ISRO GBP program, SWG on LULC dynamics and ecosystem studies, tropical ecosystem environment observation by satellite, trees 1 and 2, GLC 2000, DOS, DBT, initiatives on biodiversity characterization at landscape level, National Remote Sensing Resource Sensors of ISRO IRS P6, AWIFS 250K, and LIS3, LISPort 1:50K, among others. Many of the products of these are hosted in Bhuvan and other portals. His research contributions are recognized by Indian National Science Academy, INSA, in 2006, and National Academy of Science, India, in 2009, through the award of their highly prestigious Young Scientist Medal and many others of similar kind. Other recognition to his credit are PR Pishotri Memorial Award by Indian National Remote Sensing Award and Platinum Jubilee Lecture at 1/5 Indian Science Congress on environmental science. He has consistently published in peer-reviewed journals, written monographs, books, and is regularly invited to give invited talks in different conferences. So I welcome you, sir, on behalf of organizing team. And without further delay, I request you to take the charge of this session. Over to you, sir.
Well, thank you very much, Dr. Rajesh. And first of all, let me thank Professor T.P. Singh, for inviting me to speak on this very special day. And when I am speaking to people, those who work in the area of remote sensing, GIS, GPS, through a platform given from Symbiosis Institute of Geoinformatics, under the aegis of ISRS and SIG. It is, in fact, a pleasure to interact with you all. And when we look at remote sensing, it has emerged as one of the most promising sciences, which has a direct application in the day-to-day activities when we look at things around us. So what I tend to do today is just to take you through Earth observation system, how probably things have shaped globally, and what kind of perspectives probably India should look forward to when it comes to applications of remote sensing. So primarily, when people talk about this, it provides you a data. It provides you a data which can speak on multiple things and which can improve our decision making and policy making. In the recent past, what we have seen, the entire set of geospatial data is able to provide a very high degree of innovation and entrepreneurship. There are multiple examples from launching of satellites, making of satellites, or utilizing data sets for carrying out different activities, which have helped society, which has helped economy, and which overall helps the advancement in the technologies. Primarily, what we are looking at citizen empowerment, wherein individuals should be able to get direct benefit of this. When I say this, it doesn't mean that citizenship is not getting benefit, but most of the time, the kind of applications which are around us, we are looking more from a perspective of wherein indirect benefits are there. So this data needs to be disintegrated. It needs to be almost real time and dynamic in nature. In a sense, these are the attributes of a remote sensing data set which we look at today. More than that, people are talking about free and open data sets, and for quite good time from USGS or from other platforms, such kind of things were there. And what we have learned recently from at the behest of ISRO and NRSC, many of the data sets which are from Indian remote sensing satellites, those are openly and freely available. Then people talk about usability of these data sets and in a most actionable manner. So herein, when you look at the example of Bhuvan, which is like any other information systems or platforms which are providing geospatial data set, it stands to be extraordinarily well, because it is able to provide you disintegrated, almost real-time, dynamic, open, and usable information which could be converted into actions. And there are plenty of examples from the country and elsewhere where people are, using this. One of the best examples is when people try to monitor the sustainable development goals and try to look at how those are being achieved. So in a sense, the kind of data set which government looks for, whether it is for administrative purposes or for financial purposes, Earth observation systems are able to provide such kind of thing. And it is able to revolutionize the entire bold action of natural resource management, citizen science, and also, uplifting the private sector in terms of utilization of this data. When you look at, historically in a global platform, how probably it might have come, this appears to be the first photograph of the Earth, which was taken in 1946 from the space. And probably when, foresters or say geologists or geographers, when they looked at this data, they were very confident looking at this about the measurement of the Earth's surfaces and all. And that has altogether changed the history of, data collection. Whensoever we talk about remote sensing, so, Lancet comes as a by default name. And there is one lady, Virginia Norwood, she is often considered as mother of Lancet. So she was, one of the interns who was working with different electromagnetic radiations and communications. And then she, based on her activities and research, she tried conceptualizing something which is called as Lancet. And initially it was planned with 6 spectral bands, but subsequently, because of the technical know-how, it came out with the 4 spectral bands, and entire globe is trying to look at such kind of data sets which are available and utilizing those. And probably this is one of the first photographs of Yosemite National Park, which was taken from the Lancet. With this kind of background, what you see today, you get to understand that, there are many countries which are making satellites and which are launching satellites. So around 100 of countries are there which are able to make their satellites. And only 15 countries are the one which are able to launch it. And we should be very happy and glad to know that 5 years or 10 years back, when I used to speak like this, I used to say we are among the top 3 countries. Practically, we are the topmost country in the world when it comes to launching of satellite. It is just not around the Earth's surface, but we know it is there on Moon, it is there on Mars, there on Sun, all these kind of heavenly bodies which are around us or in our galaxy. We are able to venture into such type of places. So this is something, a big achievement which comes in the country. And we are equally good when it comes to meteorological satellites, when it comes to geophysical satellites or remote sensing satellites. And now with NAVIC or GPS, we do have a very strong contribution in global navigation system, satellite systems. So in all facets of Earth observation, or in all facets of remotely sensing or communicating onto the Earth, we are probably the topmost when it comes to remote sensing. However, when you look at how people have often talked about this, so when Outer Space Treaty was formed, so it was looked more of an exploration and use of outer space, and that should be carried out for the benefit of all the people, irrespective of degree of their economic and scientific development. This is how in 67, this was conceptualized. But I will just show you in much more advanced period, probably, the father of Indian remote sensing or father of Indian space, when we talk about, so he has mentioned about this. So today, we are definitely looking at the constellation which are around us. There are odd 9,900 satellites which are moving around the Earth's surface. You have geostationary, you have R&D, you have polar, or you have other set of satellites which are regularly providing you data sets. And most of the countries which we get to know, whether it is US, whether it is China, whether it is, entire Europe, Russia, European Union or Japan, they all are, participating on this. Again, when you look at this galaxy, India stands to be something very different out of this, which has right from beginning, which has done things in a mission mode. In a mission mode, looking at what country needs are there, how it is participating in the global forums or global missions and all. Nowadays, as if everybody talks about sustainable development goals, wherein 17 sustainable development goals are listed, and they all help somewhere in monitoring what kind of things are happening. So the missions which were there in Indian Remote Sensing or Indian Space Research Organization program, it has always tried getting aligned with the international ventures whensoever it has come to human well-being or development or management of resources. In between, we got to see something called as GIS, and Dr. Tomlinson, he is considered to be father of this. In a very early ages of his research, when he was in Canada, he proposed a Canadian GIS, and now what you see most of the time, remote sensing data sets, they work in a platform which is generally referred to as GIS. What you see as Google Earth, it had actually come with a intervention of Al Gore again in 1998, when he basically proposed a concept of digital Earth while talking to scientists in the California Science Center, and where he talked about multi-resolution, three-dimensional representation of the planet with a vast quantities of georeference data sets. So from a very academic purpose, when we look at today, we look at in a larger discipline of geoinformatics, wherein remote sensing becomes the pillar. It becomes the basis of all type of data collection, or many a times using remote sensing data as a background, many of other spatial data sets are being generated. And that comes into another platform which is generally called as GIS, wherein you are able to handle spatial data sets, whether those are in vector format being generated or raster format being captured. So such type of data sets are being used, and to get aligned with ground or to get aligned with geo coordinates or society, GPS or global navigation satellite system comes into picture. And in a larger perspective, what you see, it has emerged as a discipline of geoinformatics. And again, it is something very nice to see. And there are many institutions, universities, which are offering high, platforms for higher education in such type of disciplines. And SIG, when I talk about Symbiosis, it stands as one of the most promising institutions in this. So when entire such kind of things were happening around the globe, well in advance, we had a person in country who basically he dreamt for exploring the outer space. And I always tell this in classroom, and if youngsters are listening to me, you should watch the web series called Rocket Boys. You will get to see Vikram Sarabhai over there, and the kind of toil or the hard work he has put forward to actually realize his dream of exploring the space. Then and for quite good time, people were always trying to question the importance of space science or importance of space activities in country like India, which was then the developing countries. And at that point of time, he actually proposed such kind of intervention in the entire arena of science of knowing the things. So it was both, exploring the extraterrestrial mass, but it was more so getting connected with the planet and then people which are residing over there. And he could foresee the utilization and applications of such kind of technology on that. Then we get to see somewhere in 1970s, Dr. P.R. Krishnaruthi, who was working with Agriculture Institute based at Kerala, wherein he developed the first remote sensing application in the country. That was the first experiment of remote sensing to look at coconut rot well disease. And it was using the aerial photographs, which were giving combinations in various bands and a very low altitude photography, and very precisely using infrared. So, when people were propelling the idea of bringing extraterrestrial world together, or exploring the components of space, and also enriching the data collection, dissemination, and communication on the blue planet, and people were, in the process of drafting or conceptualizing sensors, we had people here looking with the same spirit and proving some of the things. So if you look at this was published in 1971. The work was carried out in 1970s. So it means a priori of having Landsat data set. People were there in country, and they were, aligned with the larger mission of space photography or utilization of this. Subsequently, when remote sensing actually got matured in the country, and we were, having institutions like National Remote Sensing Agency or Photo Interpretation Institute, which is nowadays called as Indian Institute of Remote Sensing in Dehradun. So there were a bunch of scientists. They tried looking at how such type of data set could be used for resource mapping. And what I'm showing you, this is outcome of the first national application of remote sensing. When I say national here, it is pan-India, across the country. Forest cover was mapped using, a satellite data set, using the cartographic tools, and reporting the forest cover. Again, this was an unprecedented effort, wherein such type of information or data set was not available in the country. And this actually became one of the turning points when it comes to applications at the national level. So you get to see somebody dreaming for such type of data sets or such type of communication. Another set of scientists taking inspiration from such dreams or such initiatives,
right,
and then developing such applications, whether it is in agriculture or whether it is in forestry sector. So we have actually moved very fast when it comes to remote sensing applications and all. And now what you get to see is, we are living in a world wherein data, technology, platforms, these all are openly available, and these could be accessed from any part of the world, provided you are just connected with internet. You have multiple softwares or packages which are coming, which are freely available or openly available, and one should be able to use. Like QGIS has become a common name nowadays when it comes to developing tools or developing databases and all. And likewise, you have wide range of platforms, whether it is Landsat, GLCN, Spot, Bhuvan, Google, which are able to provide you a variety of data sets which could be used. And when you simply just look at this open platform, which is generally called as Google Earth Engine, you get to see all kind of disciplines which exist and which people are venturing into, whether it is wetland, whether it is water, whether it is forest, land cover, crop, climate, all could be addressed very conveniently using this. And there are variety of applications which are being developed, and which are just not the academic exercises, but they also help us in formulating the policies, or also evaluating different programs which are being carried out. It also helps you in the very primary data processing, which is generally related to radiometric, atmospheric, geometric pre-processing of the data sets, or generating seamless data sets for the entire world, those kind of things. And then looking at many of the modeling or application fronts wherein geospatial analysis plays a very crucial role. So when we see today at the global scale, the kind of data sets which are being provided, you have, vegetation indices, you have variety of land cover information, forest cover information, information on the terrain, on climatic factors, and many of other biophysical factors which are generally needed whensoever you are carrying out any activity, just not for the resource management, but also integrating the citizenship over there, or also looking at other kind of programs. So most of the countries, they are hooking over to this, and India is one of the most promising countries in this when it comes to data collection, when it comes to data dissemination, or even providing data sets on the open platforms, or now you get to see examples wherein you have a free platforms wherein such type of data sets are coming. So what probably country should, or probably should venturing in much more emphatic manner when it comes to applications of remote sensing, or the way the father of Indian space science has basically looked into such type of technology. So one of the most challenging things which we are looking at is agriculture sector, whether it is food security, whether it is disasters, or whether it is appropriate land use, land cover planning, or interaction with other kind of resources like urban areas, or say your forest areas. So there is a lot of things which are happening around this in the country. When you look at from the global perspective, so there are many of the planetary boundaries which are being talked about, and they have somewhere directly linked with agriculture systems, whether it is excessive use of nitrogen, or it is greenhouse gases inducing into climate change, or transactions with the natural resources, forest resources, and those all. So with the available high resolution data sets, or with recent state of art of UAVs, one should be able to measure and monitor the actual changes which are taking place in the dynamic parts of these natural resources. So I am just showing you an example from the agriculture plot, wherein taking almost a daily photograph, or on alternate days, one is able to actually calculate very precisely how a crop is actually taking a shape. This is something very demanding when entire country is looking at multiple challenges around agriculture sector, including insurance of crops. So such type of frontier areas are available which we need to explore with. When you look at biodiversity conservation or bioresource conservation, so people who generally study biodiversity, they talk right from genetic level to landscape levels. Interestingly, when you are looking at remote sensing, it provides you a very nice spatio-temporal distribution of things, and one is very quickly and very conveniently able to assess biological resources right from landscape up to plot level or individual tree level. Even using some of the latest state of art, people are able to link it with the up to genetic or taxon level. So you have a tool which is able to link various subscales or various subdomains of resource conservation when it comes to tropical areas or the entire planet per se. So the technology is able to help us in such kind of things. People are much more interested to carry out things in a real time. You scan the Earth's surface and you are able to see what kind of vigor is there, or what kind of diseases are there, or what kind of species richness is there. You are interested to identify the gap areas, or at times you are interested to go up to canopy or individual leaf area. So you have one way scanning the Earth's surface, by virtue of remote sensing, and then utilizing platforms like data mining or artificial intelligence or other kind of platforms to process such type of data sets. When you look at the disasters which are happening around us, or the disasters which are often linked to natural resources, like recently you have seen in Wayanad, the landslide events which are taking place, at a real time, one should be able to see the things at the surface and at the subsurface level, and then identify the hotspots and accordingly plan the things. It further goes and it is able to tell us many of the unknowns, or the things which were being communicated in altogether different manner. This I like the most because I learned something out of such type of applications, which we were always told that when you look at the top predator in the ecosystem, a lion, so the female is the one which takes care of the family and all, whereas male is not participating much into family affairs. But when you see it from the perspective of geospatial data set, I am showing you a hunting view shed of males and a hunting view shed of the females. What we understand is when it comes to male, it goes under the canopies. It goes in a much more combat manner, whereas females go into open spaces. So probably, the behavior scientists or wildlife biologists who are witnessing such kind of things earlier, they were, more skewed towards as if, females are taking care of most of the such type of needs. However, when you look at technology is able to tell you how, things are probably much contrasting than what you are looking at from your field experiences and all. Here, these all are being generated using GPS, GIS, and on the remote sensing data sets. So world is changing, and it is just not world is changing. India is also changing very fast. Recently, you must have heard, the Home Minister of the country telling in the Parliament that the kind of preparations which we have when it comes to rainfall, cloud, cloud burst, or even the lightning, those all kind of processes. So what you see over here in the morning when I was trying to prepare some slides for you, so I just clipped what exactly is the rainfall at 10:30 IST today. So such kind of almost real-time data sets are available, and these again come by virtue of meteorological satellites when we talk about Earth observation system. Cyclones have not that dangerous to us because we have a precursor information on the movement or actual tracing of the landfall of any cyclone which are coming in, whether Bay of Bengal or nowadays you get to see in Arabian Sea also. Remember 1999 super cyclone which happened in Odisha and the kind of losses which we had. So our preparedness by virtue of remote sensing inputs or Earth observation inputs are something extraordinarily which could be interpreted, which could be utilized, or which could be communicated. Like one of the recent flood situation which happened in Chamoli around 10:30 a.m. Within no time, within 2-3 hours of time, people were able to fetch out the best available satellite data sets, whether these are from cartosets or these are from Planet, and then actually earmark the area from where landmass has fallen and to what slope or depth it has come and what kind of flooding situation is there. And with such precursor information, one was able to block the gates at Srinagar, Chauras, and were able to protect the remaining downstream from any unfortunate situations and all. So earlier people used to look at things like this if flooding is taking place, but for many of the cities, like I'm just showing you for Visakhapatnam, we have such type of examples from many of the cities where we have tried, simulating in case of rainfall, the areas which will get inundated and at what height, whether it is a knee height or whether it is an ankle height, and where all flooding kind of situation will take place and what resources are there. whether you have petrol pump there, or schools, or nursing home, hospitals, in small scale industries, or marketplaces. So, for most of the things, one is able to generate such type of information in the apps, and one should be able to see such kind of things just before starting the day and then actually venturing into their day-to-day activities. So with the given challenges of climate change or mitigation towards climate change, renewable energy has come as one of the most promising affairs. And when you look at the kind of NDCs India has announced, renewable energy has been one of a most thrustful area on that. So using remote sensing inputs and precisely land use, land cover over here, and then terrain conditions and other climatic parameters, one is able to assess the locations where solar potential is over there. We did this exercise around 10-15 years back, and we were able to communicate the locations from where such kind of solar potential could be tapped, and to which other locations it could be transmitted without hinge. And these all locations where it is being transmitted are the ones where urbanization is in its highest rate. It means the energy demands are very much. So as I said, the contemporary challenges which are over there, those could be done very nicely. You can go much further. You have best of the spatial resolutions nowadays, and with sub-meter kind of spatial resolutions, one should be able to map each and every rooftop. And this is the example which I am showing you. We developed at some point of time, again, 10 years back, we tried mapping rooftop of each and every building in Chandigarh. And when you click on this building, you are able to see what kind of kilowatt hour per square meter per day kind of energy could be generated using the available solar radiation. And it is just not for the months. If you click it, it goes up to week and on the daily interval. And if you know that your rooftop has such type of potential, you will definitely get motivated to hook to renewable or new energy resources like solar panels and all. What we have done, taking the benefit of the experts in this area, we have also tried computing. If you look at the roof area, and if you decide how much of roof area you want to use for solar panels, whether it is crystalline or thin films, whether you put it in grid or off grid, month-wise, it gives you the break-even point. It means how much money you are going to save if you have such type of solar potential, which is potentially tapped at the individual household level. So you remember I was saying we wish to empower the citizens for their day-to-day decision making. So such type of things are much needed, so that at the palm top, at the smartphone, one should be able to see such kind of sub details for their own assets. And if one is able to do this, probably one is directly linked remote sensing support towards the human well-being. And this is what probably the father of Indian space science has basically looked at. When I look at satellite data, and when I look at the kind of changes which are happening around the country, I can't miss this wonderful example, wherein with such a messy, interspersed and highly dense settlement area, one is able to carve out a corridor which is able to connect Kashi Vishwanath to the Ganges. So this is how technology basically enables to do planning. I definitely say over here that political will dictates over many of such kind of things. It is just not in country, it is across the world that you need such type of committed leadership to realize such type of missions onto the ground. And if one is into that, then probably your high resolution data sets are able to draw such type of contours over human settlements or over the human interventions, and one should be able to carve out such beautiful corridors. I had been to this area earlier, and after such a monumental shift has come, and it is really breathtaking that such kind of things could be done And this again is all virtue of high resolution data sets. Now world is changing, country is changing. You have entrepreneurs, you have people who are coming into this, and the day is there whereas you are launching bundle of satellites, just not bundle of satellites in such a constellation that it goes onto the space, and the moment it goes to the outer, it booms out and spells out all the satellites in such a manner that they are able to continuously monitor the Earth surface as if it is a videography of the Earth. So it is not the image which will be coming to us, it is more of a videography of the Earth which will be coming. So this poses much larger questions to all of us. The world of remote sensing which we are living in, if we have access to such type of images of the entire planet on a single day, so the questions comes, what will you do with that? So we need to think much louder, because data set is not a limitation anymore. We should look into more of a problems which one should be able to solve, and this is what most of the aspiring countries like India need to actually thrust upon. And also looking at the explorations, something which is beyond the comfort level, or beyond the imagination. So when we are talking or celebrating Remote Sensing Day, we should, scratch our heads, or we should try looking at such kind of forward-looking challenges. One of the things could be you want to do the head counts. You have some of the places like, where footfalls are very high. Can we do such kind of things? Can we develop such type of algorithms wherein we carry out the head counts? Like this is one of the examples where high resolution data set revealed something totally surprising to entire world. We all have experienced COVID, and I wish we never get to see that. But we got to learn that in December 2019, and somewhere in the first quarter of 2020, people actually realized what is COVID. But when people looked at high resolution remote sensing data sets of hospitals of China, they got to understand that, the footfall in hospitals with the symptoms like flu, that all started in the month of August. Rather, if you look at even in July, there was some kind of peeping which has taking place in such type of, parking lots of hospitals. So it means it is able to reveal something more which rest of the world at times doesn't know. And we need to explore such type of applications. Rather than applications, I would say such type of strategic activities. Like this is another, very alarming to me when I look at this image. This is of January 2021, 12 January, 17 January, 22 January. It gives me two messages. One, when entire world and the countries like India were resting as if COVID has gone, the countries like China, from where it has actually originated, they were still in process of developing hospitals, or they were developing such kind of facilities for the order of 4,000 guests could be accommodated over here. This is point number one. Point number two is see the rate of development. This is 12th January, this is 17 January, this is 22nd January. It means within 10 days, they were able to raise such type of infrastructure or facility. We need to learn both the tricks. We need to learn that, something which we hear or see otherwise might not be true. We should rely on technology or evidences or indicators which are coming from technology. Second, the rate of changes, how quickly they take such type of decisions and implement such type of things onto the ground. So probably, remote sensing data helps us in this. Another very interesting thing which I learned from one of my friends is, when entire country is looking into what kind of production has taken, what kind of MSP is there, where it should go. Land resource managers are looking in a different end of that. If we can map crop harvesting, like we have, this is a map of crop harvesting for the year 2019, March to May. This is for 2020. It means harvesting is not anniversary in its pattern. It changes, and when you are comparing 2019 with your 2020, So your harvesting process is slightly different in terms of calendar years. If calendar days, if it is true, I should be able to find out by which date, by which time your land is available. Land is available to carry out some activities. If one is able to do this, the land utilization becomes much more efficient. The kind of activities which are being done after the harvest on this land, that even could be monitored very conveniently. Like what you see, residue burning, or what you see that post paddy cultivation, when moisture is there in the soil, we need to grow some kind of vegetables. In both the ends, such kind of things could be done. I foresee that, with the given of remote sensing platforms or remote sensing data sets which we have, as a researcher, as a scientist, or as a practitioner, we should look into such type of unventured landscapes and try to find out solutions for what exactly is happening to us. Another very important thing which country has proven with wonderful strategic operations in the borderlines is the geointelligence. What I have learned from some of my friends which live their life in uniforms and all is, they are using such type of data sets, such type of images in much more efficient and effective manner than where we can imagine. Geointelligence has altogether transformed with remote sensing. Because of the strategic applications, many a times when it comes to civilians like us, we don't get to learn or understand these kind of things. But if you talk to people who develop small apps or small customized things, so you'll get to see the people who are there in uniform, they are using it like anything. It is much more dense than what you see as Swiggy or Zomato around you. Such type of frequent applications are there. At each level of hierarchy, they have their own customized design set of geointelligence, which is wherein remote sensing is being used. So we need to explore such kind of things as well, how we can further strengthen such kind of things. So I think I have tried giving you much larger or varied kind of applications. I am more of a application scientist by training, but more of a teacher now. So I simply talk in such type of languages just to see if these things could be picked up. So when I see today, I see space science more of a space service. So you have plenty of services which are being now done. So it is no more a time to celebrate it as space, only space science. I rather say the father of Indian space, his dreams have been translated into services. And we need to strengthen such type of services for the country, for the citizenship. So we all are very well aware of Earth observation, but with a very fine and high resolution data sets, there are so many other potentials yet to be explored. We all need to look into how such kind of things could be done. Probably there will be another plight which is yet to be defined as we talk about multispectral, hyperspectral, ultraspectral, or ultra-spectral remote sensing. So there will be other set of things. Then looking at communication satellites, we know that connectivity during the periods of disasters or maybe communicating through other kind of things, but there is a very strong signal which is around ourselves, whether it is your internet in mobile or your smart watches or your this thing. We need to strengthen such kind of things with our satellites and all. Positioning, though it has improved, but probably we need to look at from, if I have things in millimeters and all, how good and how fine I should be able to do. Microgravity is something very interesting, which is least talked about. But when you are sending people over there, you are making all together different type of arrangements for their health. And health is one of the challenge on the planet. So can we learn something from such type of advancements, which when microgravity is talked about, and then real customized, sophisticated solutions are being given to your space suits or space, venturing people. Now India has ventured into that. It is a very high time we should, try, rolling such type of unturned things. Space spin-offs are very much important. I don't know. I have never been to learnings of such type of sciences, but the way they are handling their waste, the way they are handling their recycling of water, the way they are handling their day-to-day activities in terms of utilization of different things which are very much part on the planet Earth. Can we learn from this such type of spin-offs? So if something is being done for space platforms or people who are going on to space platforms, can we have some kind of learning from there, and we use such type of learning to manage our solid waste, to manage our water recycling, to manage our 3R, of environmental sciences. Probably if we learn from such kind of things, we should be able to. Beyond this, something which is literally called as inspiration in its letter and spirit, a person imagined or dreamt something, around 50, 60 years back. And we are harvesting the fruits of such dream and the hard work that person has put on that dream. Can we actually inspire our youth or people around us to at least trace such type of footprints and think in similar kind of spirits and bring out something more? So for me, this person, or for me, the way remote sensing has graduated, or the entire, use of space sciences has happened in the country, or it has brought laurels to the country, it is a true inspiration. We should just not rest at the applications which we get to see. We should actually venture into and pick up the inspirations which could be from there. So thank you very much. I rest over here. And if I have made any sense to you, so probably this day is realized. Thank you. Thank you very much. Over to you, Dr. Rajesh.
Thank you, sir. On behalf of Indian Society of Remote Sensing, Indian Society of Geomatics, Pune chapter, I express my gratitude towards you. Thank you for accepting our invitation and giving your valuable time for us. And you have explored many real-time applications, recent applications of remote sensing technology as well as geointelligence. I'm sure that all the students who join this particular session, they will take it forward. So with this, I conclude this session. Thank you all. Thank you, sir. Thanks to all the participants.
Thank you, Professor Joshi. Thank you, Professor Jesu, to deliver that this excellent your speech on this remote sensing day. In fact, that you have spoke very well about this that how to manage resources while you are in space. If it is going to be translated to that the on Earth surface, that is really going to be changed. That the whole that the ecosystem where that we are living. And in fact, that you have provided that excellent example of that the high resolution data to low resolution data, how that the remote sensing program has started, and what that the use of that remote sensing data in that the humanity impact. So such kind of the practical applications which you have given, that is certainly going to be the enhance that the understanding of that the researcher practitioners, and also that the students, those are over here. So thank you for that you're giving your time to explain about that the all remote sensing program from that from very initial stage to that advanced stage. Thank you for your time, Professor Joshi, and thank you all of you for being with us in this remote sensing day celebration.
Thank you. Thank you very much. Thanks a lot.